back with a different kind of lesson. Of course, we'll still be going over today's important lesson, but we will be hosting our lesson on the MIT campus, specifically the MIT Research Laboratory of Electronics. So while we're here, why not have a little tour? Currently, we are walking into the lab space. As you can see, there are individual workstations with plenty of hardware equipment to work with. Here I have my little setup, my personal project, which we'll be using to demonstrate today's lesson. Before we start this lesson, and towards the end, a tour, let's get some background information and vocab. Sound travels in waves, like the ocean. The actual term would be sinusoidal waves, but we call them sine waves. If the waves travel slow, or low, the wavelength becomes longer, the distance from peak to peak. If the waves travel fast, or high, then the wavelength becomes shorter. The measurements we will be using for these waves are called hertz. How many sound waves appear in a second, also known as a frequency. Next is amplitude. Amplitude is the intensity of the sound. I guess you could say volume. We measure this in decibels. For example, a whisper is around 40 decibels, while a yell is around 100 decibels. For my project, we are using a sound sensor to help us measure the sound waves. When we speak, the amplitude and frequency of the sound wave is exerted as pressure, which the mic then translates to a certain voltage. The voltage is what we see on the oscilloscope right here, which helps us visualize the sound waves. Here, I have paused the oscilloscope at a random time while I was speaking. As you can see, the waves are uneven because I am speaking at different pitches. This causes an error and results in the oscilloscope spinning back no edges, because it is unable to detect where the sound wave starts or ends because of the different frequencies, pitches, amplitudes, etc. It has to be constant. To fix this, we'll be using an online tone generator to give us a constant pitch. First, we will be messing around with the amplitude. Watch as the height of the peak decreases when we decrease the volume. Now we will be messing around with frequency. Watch as the wavelength decreases as we increase the pitch. Lastly, on the oscilloscope, you can see the hertz displayed closely matches the hertz displayed on the online tone generator. Let's say goodbye to our workstation. Here we have ready-to-use appliances for students working on their projects. Around the workstation, chalkboard displays scratch work by some students. Time to head out.